Hello, Algebra 1. Today we are looking at lesson 6.1, which is a different kind of change. So here we're looking at the patterns in 3 different tables. Think about what do you notice and what do you wonder. So some things you may notice would be that the x values are 1, 2, 3, 4, and 5 in all 3 tables. And in the first 2 tables, the y values increase, while in the third, they increase and then they decrease. And the y values in the first table are all multiples of 5 and they grow linearly. In the second table, the y values grow by a factor of 2 each time x increases by 1. And in the third table, there isn't an obvious pattern in how the y values change. And some things you may wonder: is there a rule for the relationship in the third table? Will the y values in the third table continue to decrease, or will they increase again at some point? Or what would the third relationship look like if you graphed it? Here we are looking at example 2. So Noah has 50 meters of fencing to completely enclose a rectangular garden in the backyard. Draw some possible diagrams of Noah's garden. Label the length and width of each rectangle. So, if we were to fill this in, some examples would be a length of 5, width of 20, and the area would be 100. And you can pick your own numbers to plug into, but these are just a few. So length of 10, 15, and 150, 12, 13, and 156, 12.5, 12.5, 156.25, 18, 7, and 126. So these are just a few examples. And then number 2, find the length and width of such a rectangle that would produce the largest possible area. Explain or show why you think that pair of length and width gives the largest possible area. And so when the length and width are each 12.5 meters, the area is the largest, and it would be 156.25 square meters. And the table up top also shows that. And as the rectangular shape gets closer and closer to being a square, the area gets larger. Okay, moving on to example 3. Plot some values for the length and area of the garden on the coordinate plane. So I already did that, and here they are. And then number 3, the points, or number 2, what do you notice about the points? So one thing is that at first the area grows as the length increases, but then it decreases, and also the area increases more and more slowly as the length increases. Number 3, the points 3, 33 and 66, and 22 and 66 each represent the length and area of the garden. Plot these 2 points on a coordinate plane if you haven't already done so. What do these points mean in this situation? So the point 366 means that if the length of the garden is 3 meters, then the area is 66 square meters. And this is right because the width 22 meters, and 3 times 22 equals 66. So the point 2266 means that the length of the garden is 22 meters, so its width is 3 meters, and the area is again 66. And then number 4, could the point 125 represent the length and area of the garden? So it cannot represent the length and area because if the length of the garden is 1 meter, the width would be 24 meters, and so the area is 24 square meters, not 25.